So in this lesson, we're going to be learning about ratio tables. The learning target, I can make a table. I can make tables of equivalent ratios so that I can find missing values in the tables. I'll know I've got it when I score 100% on the assignment following this lesson. So first thing we're going to discuss is what a ratio table is. So a ratio table is a way to compare quantities. A table is used to organize information and make it much easier to analyze and compare the quantities. So in our first problem, we're going to learn how to put these ratios into a table. Todd earns $3 for every 5 chores he completes on his chore chart. Find the equivalent ratios using the ratio table below. So the first thing you need to note is that they gave us a rate up here. They gave us a ratio, a comparison, $3 for every 5 chores. So that ratio is going to be important because that's going to start our table. You got to pay close attention to the labels on the table so you put the right numbers in the right columns. So we have here the tables written vertically, and they put the heading of chores to money made. Chores is first in our table, so we're going to make sure we put the value for chores first in our chart. So we know that for every 5 chores he does, he makes a total of $3. Oh, we don't have to put the dollar sign in, it's on the top, so we know it's money. So that's how we're going to set our equivalent ratios up. We're going to put the chore number here, the value for the number of chores, and then how much he makes for those chores. So the next thing I'm going to do is I'm going to put in a value for chores. If he does 10 chores, how much money will he make? Well, if he does 10 chores, he's doubled his chores, so he should double his money. He makes $6. So our scale factor there was 2. To create that equivalent fraction, I used a scale factor. I said double the chores, so you double the money. Okay, the next one, let's say he does 15 chores. How much money will he make if he does 15 chores? I'm going to go back to my original ratio, which was 5 to 3. And I'm going to find the scale factor. If he does 15 chores, that means we times 5 by 3. So if that tripled, our money should triple. We got to scale everything up by 3. So he makes $9 then for 15 chores. And then let's say he does 20 chores. Our scale factor goes from a 3 to a 4. 5 times 4 is 20, so 3 times 4 is 12. So now it's a 20 to 12. And finally, our last one, 25 chores. 5 times 5 is 25, so we scaled that up 5 times bigger, so we're going to scale this up 5 times bigger. He'll make $15. So now we're going to take a look over here at this ratio. We're going to transfer the data over here, and we say the ratio of chores to total money. So again, it started off as the ratio 5 to 3. 5 over 3. I'll write it as a fraction and as with the colon. The next one was 10 to 6. Well, 10 to 6 reduces as a fraction. It's 10 over 6, but that reduces to 5/3. We leave these fractions as improper. We're not going to convert it to a mixed number because I want to see the comparison. I want to see the values right now for the chores compared to the values for the money. So our next one is 15 to 9. Well, as a fraction, it would be 15 over 9, and if you reduce that by 3, you'll get 15 divided by 3 is 5, 9 divided by 3 is 3. You'll get it down to 5/3 again. And then 20 to 12. And as a fraction, it would be 20 over 12. And 4 goes into both those. 4 goes into 25 times and 12 3 times. Not a surprise. It's a 5-to-3 ratio. Because again, we were creating equivalent fractions for these, but rather than displaying them like this, we were putting them in a chart, side by side. Finally, 25 to 15. 5 is the GCF of 25 and 15. 5, so I'm going to write that as a fraction just to see it both ways. And if I reduce that fraction, 5 goes into 25 5 times and 5 goes into 15 3 times, and all of these come out exactly the same. They are equivalent ratios. And again, we put them in a table to just organize the two categories, and it'll help us to compare and make these comparisons. So we need to figure out, how are the number of chores and the amount of money earned related? How are the chores related to the money they make? So the relationship is simply the ratio. How are they related? For every 5 chores, he earns $3. It's that simple. It's the comparison we're making. That's the relationship. 5 to every $3. Now we're asking, how are the values in the chores column related? So we're going to look at the chores column only. That would be this column right here. And what we notice is the chores always are increasing by 5. Every time we went up, we added 5 more chores to the number before it. Question C, how are the values in the total money column related? Well, when you look at the total money column, what we find is the amounts are always increasing by $3. Every time we went up to the next row, it was, or the next, next row, down to the next row, it was a $3 increase. So the total money earned increased by $3. Okay, question D, what do you notice about the ratio column? Well, you should notice that even though the numerators and denominators weren't the same, the ratios were equivalent. What we learned in the other lesson, last lesson, they all simplified to the same fraction, simplified to the same ratio, 5 to 3. So the fractions look different when we initially wrote them. The ratios look different when we initially wrote them. But when we put them all into simplest form, they all reduce to the same thing, 5/3. So it's an equivalent ratio table, is what we say about this. This table is made up of equivalent ratios. We made sure that they were equivalent because every time I increased by 5 on this side, I would increase by $3 more on this side. Every time I added 5 more chores to the pile, I added $3 more to the money. So by keeping the 5 to 3 ratio moving through down the table, I created a whole table of equivalent fractions. Mr. Baker is making pancakes and reads the recipe on the back of the pancake box. Use the information in the table to determine the ratio of the cups of pancake mix to the cups of water. So the first thing you need to pay attention to are these two rows right here. This row right here is cup of pancake mix. And then that's the powder, and then we're going to add to that the cups of water. And they give you the right ratios you need if you're going to want to increase double the recipe, triple the recipe, because you have more people coming. You might need to have 4 times the recipe. So they're giving you the right ratios so that when you mix the water in the pancake mix, it's going to taste good. It's not going to be too runny. It's not going to be too thick. Gives you the right balance so that your pancakes taste good. So if you're looking for the constant ratio, we'll start with this one right here. It says, hey, if you're just making a recipe, you're going to need 1 cup of pancake mix to every 1.5 cups of water. And then if you double the recipe, times it by 2, times 1.5 by 2, you'll need 2 cups of pancake mix to your 3 cups of water. And then if you triple the recipe, times it by 3, times it by 3, you'll need 3 cups of pancake mix to 4.5 cups of water. And then if you quadruple it, you're going to times that pancake mix by 4. And so then you also have to times the water by 4. Because remember, it's a scale factor that we're using here. And a scale factor is your multiplier. And to create that equivalent ratio, you need to multiply the numerator and denominator by the same amount, so on and so forth. So 5 times 1, 5 times 1.5, 6 times 1, and then 6 times 1.5. And that's how they generated the table. They started with this ratio right here, which is your constant ratio. And they built on it from there. They scaled it up as they went. So the consistent ratio for this table is 1 to 1.5. All right, so now it's asking how many cup of pancakes mix will be needed if there are 15 cups of water. So just looking at the chart, they're saying, hey, if we have 15 cups of water, how many cups of pancake mix of the powder should we add? So when you're looking at that, you have a few ways you can decide. There's lots of ways you can try to figure that out. One way would be to simply set up your ratios. Pick any of these ratios in the table. I'll start with 1 to 1.5. And I'm just going to put up here in word form that this is the pancake mix on top and this is the water in the bottom, so I keep everything straight. And they want to know, hey, I need 15 cups of water. That's what I dumped in, so how many cups of pancake mix should I dump in there? So I'm going to put a little P here for pancake mix. And then I'm going to look at my fractions and figure out how to scale it up. What do I multiply to 1.5 to get 15? Well, that's easy. The decimal moved 1 place to the right, so I'm going to multiply by 10 to swoop that decimal 1 place to the right. What we do to the bottom to keep that ratio the same, we have to do to the top. So I would need to add 10 cups of pancake mix if I used 15 cups of water. That's one way you could look at it. Another way you might look at it is you might like this ratio better. If we have 5 cups of pancake mix to every 7.5 cups of water. Again, pancake mix is on the top, water is on the bottom of my fraction. And they gave me the value for the water. They said, hey, 15 cups. Now, why some students might have used that ratio is because they recognize that 7.5 is half of 15. So in their heads, they're thinking, I just double. I double my pancake mix because I doubled the water for that ratio. And if you do that, you also get 10. Okay, and so you might not like this one. You might not even like this one. It should make sense to you now, but if you don't like those, maybe you like to use your whole numbers. So let's set up for pancake mix to water again. 2 to 3. And we want that to grow to 15 in the bottom for the water. How many cups of pancake mix? Well, you should easily see that 3 to a 15 is scaling it by 5. 2 times 5 is 10. So there's lots of, since these are all equivalent fractions, it doesn't matter which one you pick. Try to pick one that makes the most sense to you, the easiest one to find, and go with it. A more challenging one that I wouldn't pick would be 4 to 6. It's not that it's impossible, but you'd have to really do some thinking to realize how you scale up a 6 to a 15. And if you did do some research on that, 15 divided by 6 is 2.5, 2.5. So that would have been your multiplier. And again, you can do that ratio, but it isn't the most obvious one. 4 times 2.5 is also 10. So they should all work to generate a 10, but it's finding the ratio that you see the easiest. So the answer to this is 10 cups of pancake mix. So now it's your turn to try. This question says a cookie recipe calls for 3 eggs for every 2 dozen cookies. How many cookies can be made with 12 eggs, and how many eggs are needed for 60 dozen cookies? So you need to fill out the table with your equivalent ratios using the information they gave you right here to start you off with the table, and then answer the 2 questions. And when you're done, turn the video back on to see if you were able to fill out a ratio table, an equivalent fractions or equivalent ratio table, and answer the prompts correctly using that equivalent fraction knowledge. Okay, so you should have started with 3 eggs here to 2 dozen cookies here. And then if you wanted to double the recipe, you would have to double the 3 and the 2, 6 to 4. If you wanted to triple that recipe, that 3 to 2, you wanted to triple how many cookies you were going to have, you would triple 3 and 2 and get 9 and 6. Quadruple it, multiply 3 and 2 both by 4 to get 12, 8. And then what you would find out is if you wanted to make, how many dozen cookies can you make with 12 eggs? Well, it's right here. If I have 12 eggs, I can make 8 dozen. Make sure you put the word dozen in there. That's a lot different than 8 cookies. 8 dozen cookies is going to be 96 cookies. So big difference. So if you leave the word dozen out, that's missing out on a whole bunch of cookies. All right, and now it says part B, how many eggs will be needed for 60 dozen cookies? So I did the equivalent ratio over here as eggs. I started in word form. I just abbreviated with some variables, E to C, eggs to cookies. I put 3 to 2 because that was the original ratio that they gave me for the recipe or for the balance. And then from there, I put E over 60. I used a variable for eggs. And then I figured out my scale factor, which is 30. To scale up from a 2 to a 60 is a 30. 3 to E would be times 30, and you get 90. So it would take 90 eggs to produce 60 dozen cookies. 60 dozen cookies is 720 cookies. It would take 90 eggs to make 720 cookies. So in the table, it might be good for you to see what you're doing by putting the dozen cookies in the dozen row and then trying to figure out how you get the 90. In number sense, this number in the top is always bigger than the number in the bottom because we always are using more eggs than we're getting cookies out. 3 eggs to 2 dozen, 6 to 4, 9 to 6. The top number is always going to be bigger than the bottom number in that table. Okay, this next problem you need to try. A developer earns $6 for every 21 apps downloaded. So you have a table that says apps to money earned. Question A, how many apps will need to be downloaded in order to earn $84? Question B, how much money will the developer earn when 105 apps are downloaded? So go ahead and fill out the chart and then try to answer the 2 prompts using the information in the table. Don't forget to show some work like I did here to justify how you're getting your answers. Pause the video, turn it back on to see when you're done. Okay, so what you should have found was that in the table, you start with 21 to 6, and then we double the apps, which doubles our money. We triple the apps here to get 63 and triple the money earned from $6 to $18. If we quadruple the apps from 21 to 84, we quadruple the money earned from 6 to 24. And then we get to the question they posed. If we have $84 earned, then we need to figure out how many apps were downloaded if $84 were earned. So to justify my answer, to work it out, I did a little proportion, we call it, or 2 equivalent fractions. When I set up this equation, we call it a proportion. And I did off to the side here, I did write my, use little symbols here to keep my numbers straight. I did apps to money, just like the table is set up. When I did that, it helped me keep my numbers straight. I know 21 to 6, $21 to 6 apps, or sorry, 21 apps to $6. And then I did how many apps to $84. And what I found was the scale factor is 14 to up that amount. And when I multiplied off to the side, 21 times 14, I got 294. So to earn $84, I wrote it in a sentence, I restated up here. How many apps will need to be downloaded in order to earn $84? To earn $84, 294 apps would need to be downloaded. So I answered in a nice complete sentence restating the question. Up here I did extend the table just so I can see, hey, does it make sense? The number up top should always be bigger than the number below. It makes sense because that's the ratio, 21 over 6. It needs to stay an improper fraction. And I got an improper fraction, so I know I'm on the right track. Okay, the next question said, how much money will a developer earn when 105 apps are downloaded? Well, 105 is the top row, so I put my 105 in there. And I, again, set up the symbols here so I kept my numbers in the right order, because remember, ratios, order matters, it's important. And I did 21 to 6 again, my original ratio that they gave me. And I set that up equal to 105 over M. I used M for money. So I got this proportion or equivalent ratio set up, and I figured out the scale factor. To go from 21 to 105, I had to multiply 21 by 5. And so I'm going to match that on the bottom to create an equivalent ratio, and I get M as 30. So if they download 105 apps, the developer earns $30. So in this problem, it says use your understanding of ratios and ratio tables to answer the question. The relationships between the number of babies to the number of nursery workers is shown in the table below. Babies are in this column. How many babies are going to be at the daycare compared to how many workers there are. What is the ratio of babies to nursery workers? How many nursery workers are required if there are 35 babies? If 7 nursery workers are available, then what is the maximum number of babies they can accept? So what I'd like you to do is pause the video, study the chart, figure out the consistent ratio, and then use that information to answer questions A, B, and C. Turn the video back on when you're done answering the 3 prompts to see if you got them correct. Okay, so you should have figured out from the ratio of babies to nursery workers that it's 5 babies to every 2 nursery workers. All of these ratios reduce to 5 over 2. 10 over 4, divide both by 2, 15 over 6, divide by the scale factor of 3, 20 to 8, divide by that 4, and pull that 4 factor out, and you'll get a 5 to 2 ratio every time. The second question, how many nursery workers are required if there are 35 babies? Well, I set up a proportion or equivalent ratios, and I put B on top for babies and on top for nursery workers, so I would make sure that I kept those numbers in the right spots. B, babies, is always going to be on my top in this fraction. So 5 over 2 equals 35 over, I used N for nursery workers. I had to scale the 5 up by 7, so I'm going to scale the 2 up by 7 to get my answer to that question. If there are 35 babies, then you would need 14 nursery workers. Again, restating the question, so I have a nice clear answer when I'm done. C, if 7 nursery workers are available, then what is the maximum number of babies that they can accept? So I set up babies to nurseries again, 5 to 2. And again, I could have used any of these ratios. I just picked the simplest form ratio, 5 to 2. And I saw that to go from a 2 to a 7, which is what I'm doing, I need a scale factor of 3.5. Our scale factors are not always going to be pretty whole numbers. Sometimes you're going to have to think a little harder. 7 divided by 2 is 3.5. That's what I multiply 2 by to get 7. That's what I'm going to multiply 5 by, and I get 17.5. But that answer doesn't really make sense because you can't have half a baby. So 17.5, we are going to round that number, but we're not going to round up to the nearest because that would put me at 18 babies. And then my ratio 5 to 2 would be set equal to 35 to 18. And if I convert these to a decimal, this would be 2.5. And this number would be greater than 2.5, which 2.5 would be smaller than this. And I can't have that. I need to make sure the nursery and the babies are safe. So they have a ratio of 5 to 2, and I have to stick with that, or I have to make sure that I have less babies because I want everybody to be safe. I want there to be enough adults to help take care of all these babies. So instead of rounding up, you need to know in that scenario you would round down. 17 babies is the maximum number of babies they can accept if they have a total of 7 nursery workers. All right, we're going to use our understanding of ratios and ratio tables to answer these questions. Miss Halpert wrote the table on the board and asked her students to find the missing value. Who found the correct missing value, Erin or Oscar? So go ahead and read through Erin and how she found her answer, then read through Oscar to see how he found his answer. And then you need to decide who found the correct missing value. And when you've decided who found the correct missing value, you should have some type of ratio work showing and justifying why you selected the answer you selected. So looking over at this table, I noticed there are 2 columns and we're making a comparison therefore. And the things we're comparing are number of cups of coffee to how much that will cost. And so 4 cups cost $10.60, 6 cups cost $15.90, 9 cups, what we had to find out, and 12 cups, $31.80. So looking at Erin's suggestion, she just looked at one column. She just took the values from this column. She said, I'm going to subtract these and I'm going to get 1530 or 530. Then I'm going to take that 530 and I'm going to add it to this number right here and I'm going to get 2120. So she ignored this column completely. And this is a comparison. When we set things up in a table like this, we're making comparisons. So she should have been using both columns to make her comparison. So right now I think Erin is not on track. So let's go check Oscar out. Oscar said he divided 1060, which is money. So I set up this right here to follow Oscar's work. He took the money divided by the number of cups. When he did that, he said, hey, it was $10.60 for 4 cups, and that ended up $2.65 for 1 cup. So this table is an equivalent ratio table because when you check all of these as ratios, 1060 over 4, 1590 over 6, and then 3180 over 12, all of them turn out to be $2.65 per cup when you put that into what we call a unit rate. So by finding the unit rate, by finding how much 1 cup of coffee costs, by doing this division, we are able now to scale up that 1 cup of coffee, scale it up by 9, multiply $2.65 times 9 to get a total of $23.85. In other words, if you take the number of cups of coffee and you multiply each cup by 265, you will get your total cost. That is the relationship that ratio gives you. All right, so we have here how to organize data in a 2-column table so you can make ratios or easy comparisons and use those comparisons to find missing values in a ratio table. You are ready now to start your assignment. Good luck.